Hello, welcome to Exponents. This is the third time I've attempted to record this, and I'm hoping this time it works. So, please start a new notes page and write in your table of contents this next title, Exponents. All right, we're going to start with we're going to go back a little bit. Okay? Because exponents is one thing, but before you can understand exponents, you have to understand the concept of multiplication, right? So, when we have 4 plus 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 4, okay? When we're adding all these together, wouldn't it be much easier to do something called multiplication? Yes, it would. So, what is the multiplication fact for this problem? Well, 4 times 1, 2, 3, 4, 5, 6, 9, 10. 4 times 10. Now, do you see, did they add 10 in here anywhere? Where did we get this 10 from? 10 is just the number of 4s that we're adding together. Okay, that's going to be important to remember. So 4 times 10, and we get 40, right? Same thing with 9s. What would be the multiplication facts that would go with this equation? Instead of having to do 9 plus 9 plus 9 plus 9 plus 9, we could do 9 times 5. Same thing. Did you see a 5 anywhere in this equation? No. That's just how many 9s we have. We have 5 9s. 9 times 5 is 45. Okay? So, now we can skip over to how does that relate to exponents. Well, what if instead of 4 plus 4 plus 4, we had 4 times 4 times 4 times 4, 4, 4, and on and on? Is there a simpler way to write that? A shorter way to write that? That's what we're going to be learning about, okay? On our last example, it was 4 plus 4, and the simpler way to write that was as a multiplication problem. Well, what's one step above and ahead a multiplication problem? It's an exponent problem, okay? So, the shorter way to write this is 4 to the 10th power. Now, do you see any 10s in this multiplication problem? No. Where did we get the 10 from? That's from how many 4s we have in our equation, okay? Now, do we think this is going to be the same answer as this one? Probably not. It's going to be bigger, right? But how much bigger? It's going to be exponentially bigger. Exponentially bigger. Okay, that just means really, 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 really big. Okay, much, much, much bigger. So then, what about our 9s? Well, this one would be written as 9 to the 5th power. Well, there's no 5s in here. That's okay. That's how many 9s we have. We have 5 9s. So this is 9 to the 5th power. This is called a superscript. This mini 5 and this mini 10 are called superscripts. Okay? That's because they are above the initial base number. So here we have our base, here we have our superscript exponent. Okay? And I'll show you how much this equals. 59,049. Okay? So it's a lot bigger than our 45 from our last example, right? All right, so let's look at a couple more examples. Here we have 5 times 5 times 5 times 5 times 5, which is really written as 5 to the 5th power. We have 8 to the 4th power, which is the same thing as 4 8. Okay? Now, is this going to be the same thing as 8 times 4? Is this going to be the same as 5 times 5? We have 5 to the 5th power. Does that just mean 5 times 5? No. That means 5 times 5 times 5 times 5 times 5. going to give you a completely different answer. This one isn't 8 times 4, it's 8 times 8 times 8 times 8. It's going to be a huge number. Okay, so you've got to watch out for that. This little exponent 4 doesn't mean multiply it by 4. It means multiply it by itself 4 times. Okay? So let's go on. And look at you. You are such a stud muffin with your little blueberries and your smiley faces. And yeah, that's you. Keep it up. You've got this. Exponents aren't that difficult. Okay, so what I need you to do right now is I need you to pause the video and write 3 sentences explaining the differences between 4 times 6 and 6 to the 4th power. So what you need to do is you need to first write out, solve those problems. Solve the 2, what do they equal to? And then write me 3 sentences. This will be checked for in your daily journal grade. So make sure that you're writing your 3 sentences. Go ahead and pause the video now. Okay, so the large differences between the 2 are, well, 4 times 6 is 24, right? Relatively small number. 6 to the 4th power, that means we're going to do 6 times 6 times 6 times 6. Is that going to be bigger than 24? I think so. So here we have 6 times 6, which is 36. Then we have 6 times 6, which is 36. Then, what do we do with that? We have to multiply those 2 together. 36 times 36. So, 36 times 36. Going to multiply those. And you're going to end up getting, hopefully that's what you got when you found the answer for this one. Okay? They're super different. But what is the difference? This is the part that you need to have written down. What is the difference between these 2 types of problems? Okay? Well, this one is repeated addition, right? 4 times 6 is the same as 6 plus 6 plus 6 plus 6. And that gets you to 24, right? 6 to the 4th power is repeated multiplication. So now it's 6 times 6 times 6 times 6. Okay, those are the 2 main differences. Up top, we've got repeated addition, and down below, we've got repeated multiplication. And that's what you should have written in your journal. Okay? Now, there's a different way to say these things. You could say 5 raised to the 2nd power, or you could say 5 squared. That's another way to say it. Because if you have a square, and you want to find the area of that square, you do repeated multiplication. Equals 25. So our area is 25, hence why you can say 5 squared or 5 raised to the 2nd power. Same thing. Over here, if you had 2 cubed, okay, that means that your cube has all sides of 2's. And how you find the volume of a cube is you do repeated multiplication. 2 times 2 times 2 to find the volume of your cube. Okay, that's why you can say this as 2 cubed or 2 raised to the 3rd power. Okay? So here are some words to know. Go ahead and pause the video and copy these notes into your notebook on your Exponents notes page. Now that you have these notes copied, we're going to go over them a little bit. The base is the number that's going to be raised to a power. So down here, we have 5 raised to the 3rd power. That means 5 is our base. Okay? Exponent is how many times you multiply that number by itself. So our exponent is 3 in that example down there. Squared, we kind of went over that. A number times itself. So any number raised to the 2nd power, you could say it's 5 squared. And cubed is a number raised to the power of 3. So any number raised to the power of 3, you can say cubed instead. All right, here is our next notes page. Go ahead and pause the video to copy. Now that you've gotten our notes copied, I'm going to go over them a little bit. So up here we've got exponents show repeated multiplication. So the exponent 3 in this 5 cubed shows that you're going to repeat the multiplication 3 times. Okay, we've got a 5 here, a 5 here, and a 5 here. That's 3 5s. Now do we see 3 anywhere in our multiplication? No. That's just how many times you multiply, okay? If you were to do 5 times 5, you get 25. Then you do times the next 5, 25 times that next 5 to get 125, okay? Now going down here a little bit, our exponential form is when you write it as 2 to the 4th power. That's exponential form. Word form is when you write it out 2 to the 4th power. Expanded form, you write it all the way out, 2 times 2 times 2 times 2. And standard form is going to be our answer, right? 2 times 2 is 4, 2 times 2 is 4, and 4 times 4 is 16. Okay, so that's how our answer comes about. And I'm just going to leave this here. Da-da-da. All right, so we have some special rules that you need to copy down in your notes as well, please. So go ahead and pause the video and copy our special rules down. So our first special rule, any number raised to the first power is itself. So 10 raised to the first power is 10. That's because in our repeated multiplication, how many times do we multiply 10 by itself? 1 time, so 10, okay? Same thing, 8 to the first power is 8, all right? So our next special rule, any number raised to the 0 power is 1. 10 raised to the 0 power is 1. 3 raised to the 0 power is 1. Now, why is that, you might ask? It's a little bit complicated, but in short terms, if you're not raising it to any power, are you going to have 10? If you're not raising the 3 to any power, you're not multiplying it by even itself 1 time, you can't have 3. Okay, so it just ends up turning out to be 1. Go ahead, pause the video, and try this problem on your own. Now that you have tried the problem out, let's see how you did. This is 4 raised to the 6th power. So that means we're going to have 6 4s. 1, 2, 3, 4, 5. Okay. So when you go to multiply these two together, okay, then you're going to bring down your multiplication symbols. Some people sometimes like to bring down addition signs. Make sure you always multiply. Okay, we have this 116 left over. And let's see if you got the same number as me, 4,096. Now I've also included this little exponential cat thing, if you can understand that. All right. Here are some extra practice problems. Go ahead and try those. Pause the video and see if you can get. Actually, don't do those. Just try those. They're a little bit more difficult, but see if you can figure them out. All right. Hopefully you got these answers. If not, it's okay. These are a little bit difficult. So thank you so much, students. If you are a GT student, stick around throughout the rest of the video. Everyone else, you can go ahead and stop the video, and I will see you in class. All right, GT students. So here is an extra problem. We're going to continue working on multiplying with decimals and multiplying with our fractions, seeing if you guys can figure these out. Okay. Here we have one. Go ahead, pause the video, see if you can solve this problem. All right, here's the explanation. Okay, go ahead and pause the video and try the next one. And here is your explanation. All right. How would you describe the expression n to the x power. This is another instance where I need you to pause the video, write out about 5 sentences. We'll discuss them tomorrow in class. Thank you so much, and I'll see you guys tomorrow.